we stopped before under simple machines, we got to understand that efficiency is equal to MA over VRO times 100%, where we said MA is mechanical advantage, VRO is the velocity ratio. So we have a efficiency where N here is the efficiency. So we're able to get this, and the next step is we will now need to go to the various types of simple machines. So there are various types of simple machines which we are going to be talking about. But remember that MA is equal to load over effort, while VRO is equal to XE over XL. You understand? So XE over XL, which is effort distance over load distance. You understand? So just take note of this. Then we'll now go to the various machines now. So we have various machines which we are going to be taking step by step. We have the screw jack. And for the screw jack, the velocity ratio is equal to 2 pi r over p. 2 pi r over p, where r is radius and p is the pitch. So we have the screw jack. For the screw jack, if we are talking about different machines now, different machines have their various velocity ratios, but we know that it has the same mechanical advantage, which is load over effort, but the velocity ratio is usually different. So 2 pi r over p, where pi is 3.14. You understand? Pi is 3.14. The screw jack, and we said the screw jack is VRO is equal to 2 pi r over p. Now this is for screw jack. Apart from screw jack, we also have wheel and axle. So if we talk about wheel and axle, for the wheel and axle, the velocity ratio is equal to big arrow over small arrow. So this big arrow you are seeing here now, is the radius of the wheel, while this one is the radius of axle. So we have radius of the wheel and radius of the axle. So there are two different things. So we have arrow over arrow, which is radius of the wheel and radius of the axle. So that's for wheel and axle. Apart from wheel and axle, we also have the levers. And the velocity ratio for levers is effort over load. The velocity ratio for levers is effort over load. You understand? So that's it. So under this mechanical advantage of levers, we will just take mechanical advantage as the effort arm over the load arm. So we have velocity ratio of screw jack. The velocity of screw jack is 2 pi r over p. The velocity ratio of the wheel and axle is big arrow over small arrow, where big arrow represents radius of the wheel, while small arrow represents radius of the axle. While for the levers, we have the velocity ratio as effort over load, while the mechanical advantage is the effort arm over the load arm. Now we also have the inclined plane. The velocity ratio of an inclined plane is velocity ratio is equal to 1 over sine theta. That's for velocity ratio of inclined plane. Ratio of inclined plane is 1 over sine theta. That's 1 over sine theta. Inclined plane 1 over sine theta. A velocity ratio of levers, we have that is effort arm over load arm, right? Then we have velocity ratio of wheel and axle, which is big arrow over small arrow. Now we can also have velocity ratio of pulley. Which is when we talk about the velocity ratio of pulley system. We talk about velocity ratio of pulley system. That's where there's a little bit of challenge. So if we are talking about only one pulley, that's only one pulley, just attach only one pulley the way it is here. You do not attach the pulley to another pulley. is going to be 2 raised to power 0. So the velocity ratio will be equal to 2 raised to power 0. What's 2 raised to power 0? 1. In a situation where you now mesh two pulleys together, you have two pulleys meshed together like this, you know that the velocity ratio will be 2 raised to power 1. So velocity ratio is 2 raised to power 1, and that will give you 2. You understand? Because it's only meshed once. But in a situation where we're talking about velocity ratio of two movable pulleys, that means only one pulley is moving now in this situation. Only one pulley is moving. And the velocity ratio of two movable pulleys will give you 2 raised to power 2, which is 4. So if you are connecting two pulleys and they are both moving, it will be 2 raised to power 2, and that's 4. So that's the major thing you need to understand in this. Then if you are talking about the block and tackle system, so under our block and tackle system, the block and tackle system, what we are dealing with is velocity ratio is equal to the number of pulleys present. So if in a block and tackle system, I told in a block and tackle system, the velocity ratio is so and so. How will you know the velocity ratio? You check the number of pulleys present. Number of pulleys present will tell you that. Then we have hydraulic press. So we'll talk about velocity ratio of hydraulic press system. So we'll talk about the hydraulic press system now. Velocity ratio of a hydraulic press system is going to give you arrow square over arrow square. So this is area of rim piston. We can call it radius of rim piston. Radius of rim piston over radius of effort piston. So radius of rim piston over radius of effort piston. That's arrow square over arrow square. If you are talking about a hydraulic press system, velocity ratio of a hydraulic press system is arrow square over arrow square. Small arrow square, arrow big square, big arrow square, then over small arrow square. So radius of rim piston over radius of effort piston. Take note of this. Then we have gear system. If we're talking about the gear system now, the velocity ratio of gear system is going to give you number of teeth of driven wheel, over number of teeth of driving wheel. So we have driven wheel that is driven, and wheel that is driving. So we are going to use this to solve some questions. Just take notes. We are going to use this to solve some questions, but just take notes that we have a velocity ratio of screw jack to be 2 pi r over p. Velocity ratio of wheel and axle to be r over arrow. Velocity ratio of levers to be effort arm over load arm. Velocity ratio of inclined plane to be 1 over sin theta. Velocity ratio of pulley system 2 raised to power 0 if there is no attachment. If there is attachment but only one is moving, 2 raised to power 1. And if it is 2 attached, take that question very well. You observe that it is under screw jack. Under screw jack, if you remember, under screw jack I said velocity ratio is equal to 2 pi r over p. Now if you check that question very well, they gave us the value of arrow, which is 24 centimeters. Now we cannot use 24 centimeters. We have to convert 24 centimeters to meters. So we divide by 100. So this will give us 0.24 meters. You understand? That's the first thing. Then the next thing, they gave us P. They gave us the pitch to be 2 millimeters. So we are going to divide 2 millimeters by 1000. And this will give us 0.002. Let's check. 1, 2, 3. Yes, 0.002. So this is meters. So the next step is to go to this formula. Velocity ratio is equal to 2 pi r over p. So we have 2 times 3.142 times r, which is 0.24. 0.24 over p. What's p? P is 0.002. 0.002. If you divide this now, you have 754.08. 754.08 as our answer. You understand? So just take note of it. 754.08. And also take note that velocity ratio does not have a unit. No unit. Velocity ratio has no units. It has no unit. Take note. Velocity ratio has no what? Units. So velocity ratio has no units. Take note. Question here. We are working with wheel and axle. So just check. Working with wheel and axle. If you go back to what I wrote about wheel and axle, under wheel and axle, we have that velocity ratio is equal to arrow over arrow. You understand? Working with arrow over arrow. So if we're going to be working with arrow over arrow, we're going to check very well the radius of the wheel and the radius of the axle. What's the radius of the wheel? 30. What's the radius of the axle? 10. So we're going to divide it. Because it's centimeter, there's no need converting to meters. So because the centimeter will still cancel the centimeter and to go. So we have 3. The velocity ratio is 3. After getting that velocity ratio to be 3, you need to find the mechanical advantage. A mechanical advantage is load over effort. Now you check what's the load. The load we have here carries a weight of 500 meters. Like I told you in the beginning, that load is a form of weight. You understand? They are carrying load. They are telling you are carrying load. So that load is weight. There was the effort you apply to move that load. That's 250. So from there you can just check 250 here and 250 here too. So mechanical advantage is equal to 2. So if mechanical advantage is 2 here, the velocity ratio is 3 here. How do we get the efficiency? Efficiency is equal to mechanical advantage over velocity ratio times 100%. And this will give you 2 over 3 times 100%. So what we have here will be 66 2 over 3%. This is what we'll get as our answer. So efficiency is equal to 66 2 over 3. Or can say percent or 66.67%. So that's how we get our answer. So just understand the question, the nature of the question. The question will determine what you are going to use. Like this is wheel and axle now. When you are dealing with wheel and axle, you are dealing with radius over radius. Very well. They said a machine is used to raise a mass of 150 kilograms vertically through a distance of 3 meters in 1 minute. What is the power generated by the machine if its efficiency is 60%? You understand? So first thing is you just have to go back to the formula which you already know, which is power is equal to work done over time taken. So if power is work done over time taken, remember that work done is force times distance over time. So they gave you the mass. Okay, so the first thing is we'll look at this critically. And what we have here is potential energy and not kinetic energy. What we have here is potential energy and not kinetic energy. So we will not use this formula. So we can just change this work done now to be mgh over t. Mgh over t. So this is mgh. This has to do with potential energy. So if it is kinetic energy now, it's another formula. So the mass we're given here is 150. Mass was given 150. We gave acceleration due to gravity, which is 10. They gave us distance or the height, which is 3, and they gave us time. And time is 1 minute. But you cannot use 1 minute. You use 60 seconds because you have to convert that time to seconds. So 0 here, 0 here, 3 here, 1, 3 here, 2, 2 here, 1, 2 here, 75. So what you have here is 75 watts as our power. So power is 75 watts. So just take note of what you have here. So you see, we didn't even use efficiency. Did we use efficiency? We didn't use efficiency here. What we just used was the parameters we were given. But just take note that we cannot use